Okay, so let's take a look at graphing a logarithm. So log base 2x y equals. Now how do I graph that? Well, I'm going to start by graphing the base to the exponent. And I'm going to do that with a table of values. Seen in the last chapter, I'm going to go rather quickly. So I choose some x values. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. Please review your grade 9 exponent laws and last chapter. Negative. So now I can put these points on the graph. Negative 1/2, 0, 1, and 1, 2. We also learned that the number off to the right, plus 0, is our horizontal asymptote. HA, y equals 0. And I can put that horizontal asymptote in, and then I can sketch my graph close to the asymptote through the points, and we're going up and up. So I know that a log function and an exponential function are inverses of each other. We talked about inverses in chapter 1, and we'll discuss that more throughout this chapter. So I simply take all the x and y values and switch x and y. And I do that again, and I do that again. And then I plot those points on the graph. So 1/2, negative 1, 1, 0, and 2, 1. Another thing that we know is from 8.2 in the restrictions, we know that the thing we're logging needs to be greater than 0. So we just set this thing, whatever it is, greater than 0. We also know that we have a vertical asymptote, seen the first time in grade 11, at x equals the thing we're logging. So I can put that vertical dotted line in. And then I can draw my graph close to the asymptote through the points. So a logarithm is an inverse of an exponential. If I want to graph a log, I simply graph the exponential, switch x and y, and then plot all my points. Keep in mind the asymptote at y equals 0. If I switch x and y, I get an asymptote at x equals 0. Lots of things to consider. Now we'll take a look at transformations of a log function. So what if I want to graph something very similar to what we did last time, but instead say x plus 2 in brackets plus 1? Again, I have base 2, so the first thing I would do is I would graph 2 to the x. Then again, I would make a table of values and switch x and y. Then I would just do transformations. So the x plus 2 inside of the brackets is a horizontal translation equaling negative 2 from chapter 1. And the number off to the right is a vertical translation up 1. So I can just simply take my old points and move them to the left 2 and up 1 and put a new point on the graph. Working through each of those points one by one, left 2, up 1. And again, the last point, left 2, up 1. Excuse me. Now I need to work a little bit more on my vertical asymptote. So my restrictions from 8.2 says the thing that I'm logging needs to be greater than 0. So x needs to be greater than negative 2. And my vertical asymptote says the thing that I'm logging needs to be equal to 0. So x equals negative 2 for my vertical asymptote and my domain restriction. And my vertical asymptote, I can put in a vertical dotted line. And we have our new graph close to the vertical asymptote through the points and up. So we have log base 2x and log base 2 x plus 2 plus 1. Recapping, if I want to graph a log, I graph the base to the x. I know they're inverses of each other, so I switch x and y, plot all those points, and then use my knowledge from transformations to figure out what happened to the graph. Notice you can see the graph has gone left 2 and up 1.